Time for the next bit of fun I promised you, and that would be this thing. This is a suitably awful UPS that came from a customer. It's just packed up, it's beaten, it's abused, it's just not really worth much grief. But being fairly basic, it's probably a good one to tear apart and just see how UPSs work. So let's pop you in the stand and take the thing to bits. Right, here we go. So, there's already quite a worrying sign here. I don't know, it just about shows up. A lovely yellow patch just there. If we flip it up, you can see that one. This is not a happy UPS, not at all. It was found in a comms rack squeaking away to itself, which we need to avoid there. There's not even a screw in there. Okay, this does not bode well. So that screw was actually mostly out. There's always a worry with things like this. Someone's been in there and said, oh, it's just a lead acid battery, we'll change that ourselves. Yeah, that's what was normally in one of these, but unfortunately you can get it wrong, especially if you go and buy your replacement batteries on eBay. That's never a good start. Incidentally, I'm not going to be gentle with this thing because it is not going back together. Okay, one screw, but it's fallen apart. The front's come off. There's electronics in there. Okay, that is suitably awful. So we have, I don't know if you can see it there, yes you can. So we have a random board here just flopping around in the breeze, although it does look like it may have once been attached to something. I have my suspicions that this was dropped. So how do we go forward? Right, we need to lose that. So that's nothing special, that is just a very complicated button on an LED. Why do you need that many, screw's gone, pins for a button on an LED? It seems somewhat overkill. Why? It is. Okay, I'll give them it's a latching button. Why is that so complicated? It's not even a bicolour LED, it's just a green LED. Oh, how bizarre. So, well, it's not unusual with something like this to find that you've got extra components for the model you don't have. Let's get rid of that. However, normally, if we're not going to fit these LEDs, I'm not deliberately throwing things around in this case, you wouldn't generally stuff those as well. And up here, and maybe you wouldn't use the whole connector, just it's the economies of scale. You're only saving, by doing that, you'd be saving probably about 5p, but you imagine how many of these they make. Okay, not impressed so far. Right, I think the start of our problems is going to be that. So let's just get rid of him. Where is my meter? It's over there. Right, I'll have a look at that in a minute. Quite often, if you're taking an APC UPS apart, a lot of them use, gone for ASCII art there, a lot of them use fairly standard lead acid batteries. Even the APC ones that tell you that you must buy the APC packs, you'll quite often find that they're off-the-shelf batteries. It's not unusual to find them being UASA or something similar. Right Art I have heard of before, but this is just a bog standard, and it doesn't actually give specs. Yes, it does. Sort of. I believe that's a 12 volt, 12 ampere hour. Right. And I'm willing to bet it's so far gone. Let's just see if we can manage this like that. What have we got? It's not actually that bad. that in theory would charge and run, which means there may be something else wrong with this. The heat marks we saw are actually nowhere near the battery, so we'll put a load on that and see if it's rescuable. They're often useful for little projects and things like that. Right, how do we get... Right, so that big mark on the bottom is the transformer. Sorry for knocking it. Aha! Right, okay. So we can pull those off. Oh, there's a tab on the underside. Pull that off. What else have we got that we can randomly pull off? That will be... Okay. Change of tools required here. Where's the hooky things? So, again, this is not going back together. I did entertain the idea briefly of seeing if we could reuse this and if it was just a battery problem, but no, it's not. Okay, fairly cheap and nasty board in there. Just so I can more easily remember what's going on. We'll do that. Right, gubbins over here. So this is fairly boring. There's not really anything interesting in here. Big transformer. Now, the way they generally use this is quite clever. Typically, when you're running on mains and all is well, I'm going to sit down. You'll be getting powered from the mains, and the mains is also fed into this, and then this doubles through these windings as a low voltage transformer. I mean, obviously we're charging a battery, we're charging a small battery, so that's wires are a bit overkill, and the reason for that will become apparent in a second. You've got all your mains. That is very close. It would not take a great deal. Bear in mind, this is all plastic. It would not take much to slam that back against that. I could actually force that into there. So certainly at least getting in there and just cutting those off would help, but that is horrible. It would not take much to short that. Anyway, back to transformer. So yeah, from running on mains, you've got mains coming into here. You've got multiple taps here. I assume, it doesn't actually say. I would assume it's quite common with these bits of kit for them to be 110, 240. So there's possibly some kind of tap going on there. There's possibly a sense winding in there as well. We could meter it out, but I'm not sure it's worth the grief, and we can probably see it on the board anyway. So when it all goes a bit pear-shaped, your mains goes out. These are suddenly driven by this massive array of transistors under here. And then it becomes basically an inverter. I certainly would imagine there is a level of main synchronization goes on here. Because you could build something like this, and indeed I've tried, with a simple inverter and some relays. It doesn't work. You need to know exactly what cycle the mains are at and match it to that. I've come on a long way since then, so I wouldn't try that now. So, but yeah, that's just a big lump of iron. Oh, a very big lump of iron. In fact, I suspect there might be some merit in making spot welding material out of there. Right, okay, so let's just have a go at this. We've only got 2 screws left. Oh, no, we've only got 1 screw left now because that's just sheared off the case as well. I'm not sure what this plastic is. This daughter board here holds everything in somehow. Well, there you go, kids. There's your surge arrestor for the telephone socket. Utter garbage. So, would they be so devious to do those back screws up? No. Just make sure I'm still in frame. Right, so here's your board. So these two we know, these are your battery connectors. this here is the mains. Now we have, what have we got there? So we've got a big chunky red one down there. They're usually marked. There we go. There it is. So that's fused. So yeah, so what would generally be happening here is your mains is coming in, comes in on these, goes through to your relays, and the relays route the primary, or depending on which way you're powering it, the secondary side of the power supply. In fact, it's written there. This one is slightly different. So you've got charge neutral and charge live, and then you've got tap TXL1, and then that one isn't marked. So there might actually be treating this as two separate transformers and not reusing the windings. That would explain why there's 5 connections there. Quite often you will literally have 3 out of the charge, 3 out of the low voltage side, 3 out of the high voltage side. It's not a wonderful board, it's a fairly cheap board. But you've got all sorts of relays going on down there, and these control how your primary windings are connected and where your mains comes from. Incidentally, I didn't see. Okay, so your mains is actually coming in here. Unusually, it's well marked, and that's your output. So there's the MOV there for your output protection. This relay here, which is a fairly standard piece of kit, tiny little sense traces on there. I'm just trying to see. No, that's the coils right up against. That's interesting because that there is the live. I realise they ground it out there. That's fine. Use your creep and your anti-creep and everything, but that's very close to those coils. But then again, you shouldn't really be touching any of this. There's no. Oh, there is a serial port. The serial port is isolated. So we've got this board there. There we go. You've got opto isolated. So the serial port's isolated. And I guess if the whole thing is hot, you're not that worried. It's just going to blow things up. It's not ideal on a piece of equipment that's supposed to be protecting things. And you can see there are a lot of slots in here. So what are we doing there? So there you go. There's your live in. That comes through to the relay and then goes straight to your output. I don't think I mean that. No, that's the neutral. We're switching both poles here. So this isn't a changeover, this is a double pole single throw. So that's your neutral, that's your live. Not quite sure what's going on there, but there is. Again, they quite often reuse boards for different models, which is why you're seeing a lot of stuff here that's not populated. We've obviously got some more wiring in there. Quite often with the APC ones on the lower models of the range, you'll find your switching transistors, which are these there. Let me just get rid of those. So you've got your switching transistors here, and these form the basis of your inverter. And we've got an LM317 voltage regulator here, so that would be the logic supplies, I would imagine. Yeah, that's all fairly isolated. So these are switching your battery. When the UPS goes into basically inverter mode and it's providing mains, these are switching into your transformer. And looking at it, we're switching the negative into the brown and blue, which means our positive for the transformer, which was, oddly enough, red up here, is connected straight to the battery. Right, okay, so that's fine. So your battery comes in through those fuses, and a cheaty way of getting a big enough fuse. A lot of UPS manufacturers on something this large use the bolt-through fuses. But I've seen this quite a lot as well. That comes through your fuse, straight out to your transformer, and that's your live side. So there will also be part of this. In fact, I now have a horrible feeling that this LM317 is a fairly common, you can go look for it on the internet, float charge circuit for the battery. It works, it does the job, but it's normally a bit nicer if you actually keep an eye on your battery and see what's going on, especially on a bit of kit like this. You can't normally just float charge the whole thing. And I'm curious because it doesn't seem that the micro has anything to do with that process. It's possible. No, what are we monitoring there? That's on the back of those diodes. So that will be rectification. So that's, again, that's where your low voltage charge is also coming back out. You've got these diodes here, which are acting as rectifiers. You've got another transistor. There might be some battery management going there, I don't know. I'm not convinced. What's that relay doing? So we've got live. Live comes in, goes through that. That is possibly... Jumpers going over here. Okay, that's possibly the output for the charge side of it. So we're definitely not reusing that primary. So we've actually got 3 sets of windings on here. And then what else really is there here that's interesting? We have what looks like a Freescale micro of some kind. It does look like we're reasonably well marked up. So what have we got here? 700 to 800 VA, 40 amps, 32 volt by 3. Okay, that's fine. So we're 3. So we're that. Now this is what I said about there being different versions. This is obviously the higher end one because you've got here 400 to 500 VA, F40 amps, so 40 amp fuses. That's what we've got, but there's only 2 of them. And we've actually unusually got options marked here. So we've got here AVR or no AVR. Masks, what does that mean? Mask 3 or mask 3. Volts or no collected. That's possibly a mask micro then, and that's what that's about. And then we've got standard, step or gen there. And that's an option for these resistors. Here we go. Again, I don't think it matters how close I bring this, I don't think you'll see it. You've got 500, 400 and 700 VA, so there are obviously the versions of this I've got. And then we're marked between this jumper and the resistor. So that partially determines what VA we are. And this is not an auto switching one because we've got here 110 volt, 120 volt, 220 volt, 240 volt. And those options are controlled by, surely not a cap, that would be stupid. Jamicon caps, not one that really rings a bell, I've seen them before. We've got another option here called mask, so but yeah, there's not a lot to them. A lot of the brains is about synchronizing the changeover and deciding when to change over. It's fairly easy to design a simple 12 volt UPS for a piece of equipment that you basically use a relay, your mains goes out, you switch to your battery, the mains comes on, the relay energizes and the battery comes back on, and you can do that with one of these in a relay. It doesn't work. Not on a main system, it works reasonably well. However, especially if you're using it on a generator, when a generator starts to fail, it will hunt. And you'll find that your voltage dips, comes back up, dips, comes back up. And every time that happens, your relay is cycling, which, if you've got electronic equipment, isn't good. If you've got lighting equipment on the end, as anyone that was at Great Dorset when we were working a couple of years ago, it produces an interesting disco effect. It's really not conducive to a hospital environment. So there is normally a level of intelligence in the micro that says, right, okay, the mains is starting to dip. We're going to go on to battery. And then generally you'll wait for the mains to come back, and then you'll wait for a period after the mains has come back before you switch back. in our gear, we also look at things like frequency, and that you can see from the mains frequency if you've got a generator that's hunting or a generator that's become unstable. Quite often, if you've got a generator that's just generally unwell, carburetor problems, or just can't sustain the load anymore, as you approach the generator's maximum load, the generator will start to brown out, or it will start to, the revs will start to drop because it cannot bring its speed up again. And you'll see that because the frequency will drop as well. Unless it's an inverter generator. Incidentally, this is pretty much the kind of thing you'll find in an inverter generator as well. So yeah, there's a fair amount of intelligence that goes into it. But anyway, enough of the nattering. That's inside a really cheap UPS. I might take one of the APCs apart just to give you a look in comparison a bit later. But I don't think what there's... obviously there's useful parts here. We know this has failed either because of the transformer problem or a battery problem and was working. So provided you go through and you test all these components, there's plenty of stuff for your scrap box in here. The relays, depends on the life that it's had. I mean, if it's just for a little bit of a fun project or something, not something you want to work too long or too reliably, then yeah, by all means take the relays. But these are switching large inductive loads and obviously switching the load of the battery, so the contacts may not be in wonderful shape. And again, you can see ever so slightly the board's baked. We know it's got hot. I wouldn't necessarily trust any caps, but transistors, absolutely. That LM317 is probably good. The power resistors, I don't know why you'd reuse them, but you probably could. There's a D9 there. There's an isolate. That looks like an isolation module just for serial. That potentially has a usefulness. I think that's interesting. That looks like an isolated USB port as well. So there's plenty of stuff that you can use, especially from older power electronics like this, that you can roll back out. So yeah, I think what I will do is I will pull apart an APC UPS a little later, and we can compare the build quality. A lot of people don't like APC. Yeah, there are problems quite frequently having to remove the batteries with a crowbar, but there are fixes for that, and there is a known design problem that has been addressed. So as with most networking gear, you get people that like the brands that they use, and there's not necessarily a reason. Anyway, I hope you enjoyed, and back soon.